that we will build is for a cat hostel. You'll be able to add cats to its database, remove cats from it, and list them. Why cats hostel, you ask? Because as long as you know how to implement basic operations like creating an entity, removing it, and listing the entities you have, you can build this kind of service for anything. Supermarket orders, auction items, taxis, you name it. So why not cats? Let's talk a bit about course agenda. We'll start with basics of Kotlin programming language. Then we'll discuss dependency management with Gradle. Then we'll cover Ktor web framework, how to test our application, how do we work with databases using exposed DSL. Then we will run our Kotlin application inside Docker container and Docker Compose, and finally we will deploy it to Heroku. What do you need to know before starting this course? I expect you to know some kind of web technology, be it JavaScript, PHP, Ruby, or Python. You to be familiar with terms like request, response, JSON, and HTTP headers at the very least. Also, there is a need to be familiar with Git. I'll provide you with a link to the relevant branch on GitHub after most of the videos. I'll show you commands that I use, but I won't dive deep into them. Basic SQL and Docker knowledge is useful, but not mandatory. I'll do my best to explain what I'm doing at every step. And most important, there is no need for knowledge in Java or JVM ecosystem. This is absolutely not required. There are a lot of great courses on Kotlin that expect you to know that, but in my course I expect you to have zero knowledge in that particular area, and I'll explain everything that's related to it. What this course doesn't cover though. So first, building UIs, CI tools, and security. Each of them is a large topic by itself, and I wanted to keep this course as focused as possible so you'll be able to produce a working and well-tested application in an hour or two. So, are you ready? Let's get started. We'll start with setting up our project and creating Hello World in Kotlin. So, what you will need? First of all, we'll need IntelliJ IDEA, which is open right now. I'm using the community edition, so it's free. JDK 8 or greater, and for chapter 5 and on, we'll need Docker. If you aren't sure whether you have JDK installed or not, or which version of it you have installed, don't worry, IntelliJ will handle versions for us, and if you don't have JDK at all, we will install it on a later step. You may be asking yourself, what is JDK and why do I need it? It's quite simple. JDK is JRE plus compiler. But then the next question comes, what is JRE then? So JRE stands for Java Runtime Environment. If you're coming from Node.js, it's your node. If you're coming from PHP or Python, you can think of it as your interpreter. That's all you need to know for now, really. Okay, but this tutorial is about Kotlin. Why do we speak about Java then? So, Kotlin uses Java runtime. It uses this JRE and JDK. It's the same with TypeScript, for example, language that uses Node.js runtime to execute. While TypeScript is transpiled into JavaScript, Kotlin is compiled into JVM bytecode. You can think of JVM bytecode as sort of assembly language. Kotlin, Java, Scala, and other JVM languages are all compiled into the same JVM bytecode. Okay, after we have that one figured out, let's open our IntelliJ IDEA and create a new project. When choosing type of your project, choose Gradle and then Kotlin JVM. In Project SDK, you can see what JDK version will be used for this project. Choose JDK version 8 or higher. If you don't have any JDKs in the list, you can download one from jdk.java.net, or if you're using OS X and have brew, simply do brew cask install java. On this screen, we choose package name and project name, like GitHub repository and the project. And on the next screen, we can rename our project if we want to. At the bottom of your ID, you will see some Gradle download messages. Wait for them to complete. When done, you should see the following folder structure. We'll discuss what are the different files and folders used for in the next session. In the meantime, let's create main KT file under src main Kotlin folder. And we'll put the following code in there. In languages such as JavaScript, PHP, or Python, code is interpreted line by line. If you put something like or in your file and run it, it will be simply executed. Kotlin uses a different convention, and it looks for a top-level function called main. If there is no such function, JVM won't know how to execute your code. If everything was done correctly, you should see a little play button on the left of your code. Press it, and in the console you'll see Hello Kotlin Web. With this, we will conclude our first tutorial. In our next tutorial, as promised, we'll discuss all this Gradle stuff in more detail. At the end of each video, I'll also provide you with a link to the current state of this project, so you can start when we finish the previous one. In our second video, we learned how to work with Gradle to add some libraries to our project. As I mentioned in the previous chapter, Gradle is a dependency management tool for JVM platform. You can think of it as NPM or Yarn if you're coming from JavaScript ecosystem, for example. Unlike JavaScript projects, though, Gradle provides you with some basic structure of your project. All code resides under src directory, application code is located under src main Kotlin, and your tests are under src test Kotlin. At the root of your project there is build Gradle file, which is similar to packaged JSON. Although it's not JSON, it's still quite easy to understand. Most interesting part for us at the moment is dependencies block, which probably looks something like this. Depending on your IntelliJ version, you may also have other dependencies there, such as test-compile JUnit or others. Now let's add two new dependencies to this block. Another way to specify the same dependency would be those two are the same and you'll encounter them in different forms in different examples. Since same version number is repeated twice, we can extract it into a variable. That's some name that we give it. And then we can reference it. After we've done that, let's understand what those dependencies are and why there are two of them. First is Ktor itself. Ktor is a web framework similar to Express.js, for example. But why do we need the second one, the native stuff? When you work with Node.js, there is out-of-the-box HTTP model you can require to start HTTP server on specific port. That's an embedded server that you control from within your code. For example, you choose which port your server will listen on. If you're Node.js developer but never did something like that, that's because Express.js does it for you. JVM didn't have out-of-the-box HTTP server until recently though, so projects such as Native were developed. Ktor doesn't force you to use specific server. That's the reason Ktor Server Core and Ktor Server Native are separated. You can decide later on to replace Native with another web server such as Jetty or Tomcat. To make sure everything still works, simply run your main KT file again. You can also choose to enable auto-import, it will help us later. So our dependencies were added successfully. In the next video, we'll start using Ktor and create our first web server. In the previous video, while discussing how Gradle works, we already introduced Cater dependency in our project. Now it's time to use it. In this video, we will create a web server that would respond to our requests. Let's go back to our main KT file and add the following lines. First, we specify on which port our server will be. Then we define our server. Then we define what this server should do. Then we start our server. When importing, make sure that you import the correct get. The correct one is from io cater routing get. First, let's see that our project starts. Now let's open terminal and see if it works. So we will be calling our server now. Make sure that you specify the correct port. If everything went correctly, you should see the response from our server. Now let's break down what just happened here. First, we configured our embedded server, specifying Netty as its engine and 8080 as its port. There are also some other parameters to configure, but those two will be enough for us for now. The fact that we configured our server doesn't mean that it has started, so we invoke start function on it. Let's go back now and take a look at the routing block. Different web frameworks take different approaches to routing. Some, like Spring, use annotations on methods to map between methods and URLs. Others, like Ruby on Rails, use mapping files. Cater takes third applicative approach similar to Express.js, for example. Note that inside routing block you can use methods such as get and post, which are not available outside of it. What if you wanted to return JSON instead of text though? Then you'll have to add another dependency to your project. So we'll go to the build Gradle. The dependency we need to add is called Cater JSON. And it uses the same version as our Cater. JSON is a Java library that converts objects to JSON and vice versa. Now we need to tell our server that if we respond with an object, it should be converted to JSON automatically. Let's add the following block before the routing block. Make sure you use the correct imports. If at some point you see that you cannot use JSON dependency, you can go to Gradle and then choose reimport. That's basically like npm install. If everything is done correctly, we can import now the JSON dependency. You may wonder why there's another set of curly brackets after JSON. That's where different configurations come in. For example, you could ask JSON to auto-indent your JSON. This will output a formatted JSON when we ask for one. Finally, we would like to replace our respond text with the following line. Instead of respond text, we'll use respond. And then we'll return a map. Our map has one key value pair. We're using two functions to create pairs in Kotlin. Now if you open URL in the browser or in command line again, we should see the following result. As you see, now our server returns a JSON. That's really nice, but still not very useful. After all, returning the same response all the time can be amusing only so much. Let's add another route with some parameters on the URL. It will be a get route, and our parameter will be called name. As you can see, path parameters come between curly brackets and are available on context parameters. Now let's rerun our server and see what happens. As you see, new endpoint returns us a JSON with cat name as a key and snowflake as a value. That's exactly what we send it. You may see in some examples that instead of using context, call is used. Currently, call is an alias for context, so you could use either one of the two. By the end of this video, we have a web application that is somewhat interactive. It has a default response, as well as able to return what we sent it to as JSON. In the next video, we'll discover how to test this application well. In this video, we'll learn how to test our newly built application so we could easily introduce changes to it. In the previous video, we built a web application with two endpoints. Or did we? Let's open our localhost and see. Everything looks fine, but that took me quite a lot of time to make sure that everything works. I would like to save this time, and in order to do that, I would write some tests. Going back to our folder structure discussed in chapter 2, we have test Kotlin directory exactly for that. If you don't have it, let's create it now. As you can see, IntelliJ and Gradle already recognize this directory as a text directory, and it's marked in green. Now we will add a new dependency, this time only for tests. And we'll let Gradle download this dependency. In the meantime, we'll create our first test. Let's create a file called application.kt under test Kotlin and put there the following content. If the test annotation is not recognized, we need to add another dependency. So we go back to our build Gradle and add JUnit dependency. I'll explain what JUnit is in a few moments. And the second one will be test runtime. We can also extract the version of JUnit. Now let's go back to our test again. As you can see, now we can import the test annotation. And that's our first test. Let's understand what this JUnit is now. There are two prominent JVM test frameworks, JUnit and TestNG. You can think of them as Mocha, Chai, and Karma, Jasmine of the JavaScript scene from a few years back. So you have this runner and you have those test annotations. That's why we have two dependencies. But unlike Mocha and Chai, those two come from the same library. Nowadays it's of course mainly jest in JavaScript world, but it's still a good metaphor. In this example we'll be using JUnit, but tests written with TestNG in mind will look pretty much the same. Note how IntelliJ recognizes that it's a test file and allows you to run the entire suite of tests or just a single test of your choice. So you can run only a single test or the entire suite. IntelliJ knows that because we used this test annotation on one of our methods and because we put the file in the correct place. Now let's go back to our application and make it suitable for testing. For that, we'll break it into modules. In your main KT file, extract the block you provided to embedded server function to a separate function called main module. Then let's make this function an extension function of application. This may have sounded a bit complicated, but it just results in the following code. Now to use this function, replace the previous declaration with the following. The double colon operator is a functional reference. Basically, what it says is when embedded server starts, call this function. That provides us with two advantages. First, our main function is now much smaller. Second, and that's what this video is all about, we can test our routing logic decoupled from what server engine we actually use. So we refactored our application to be more testable, and in the next video we'll start creating tests for it. In the previous video we refactored our application to be more testable. In this video we'll start creating our tests. Let's go back to our test file and implement a test for something that should be working. Function with test application is part of Ktor testing library, and it simulates our server without actually starting it. We use handle request to issue a call to this test server. Then we check that the content of the response is what we expect. Since response is a JSON, we use triple quotes to preserve formatting and trim indent to remove invisible characters. Let's see that it works. If your test fails, you can see the difference. Let's run it again. Now everything is green. As you've seen, the test may or may not pass based on the indentation, which is not optimal, of course. Probably, as happened with me, our JSON may contain some unexpected new line characters or spaces. Let's make this test more stable. To parse string to JSON, we'll use JSON library, which provides object mapper for that. Make sure that you use the correct import. Once you have instance of the object mapper, you can use read_tree method to parse your strings to JSON. And we would like to compare JSON to JSON. Let's test it again. It still works no matter which indentation we use now. There is another neat trick we can use to make our test look nicer, and it's based on extension functions. Add the following declaration. Now you can remove instantiation of object mapper from your test and simply rewrite your test like that. Content may be null, so we use this question mark on it, so we won't get any null pointer exceptions. Last thing we should mention before moving on is that in the future versions of Kotlin language, we will have its own JSON parsing library in Kotlin serialization package. Currently it's still experimental, so we decided not to cover it in this video. Now let's add another test. So again use with test application. And let's see that we get the correct status. One last thing we'll do is dive a little deeper into how routing works. For that, add the following dependency into your build Gradle. Now let's go to the routing block and add the following. Let's restart our application. You should see something like that in the output. This will help you in the future to understand what routing paths were chosen by Ktor, and is very useful when your application doesn't behave as you would expect it to. Now you know how to test your Ktor application and also how to work with JSONs. In the next video, we'll see how this application can persist data in the database. And as usual, here is a link for the results of this video. In the previous video, we covered how to test our web application. In this video, we'll see how our application can store information using a database. Application that we were working on until now is still not very useful. It's somewhat interactive, able to echo what you sent it back to you, but it's not able to remember anything. In this chapter, we'll fix that by connecting our application to a database. For the purpose of the example, we'll use Postgres, but any other relational database such as MySQL would work pretty much the same. It's also possible to install Postgres database on your machine without using Docker, but for development purposes, it's a clean and convenient way. If you're not sure whether you have Docker installed, run Docker in your terminal. If you don't have Docker yet, follow this link and choose relevant operational system to install it. Once you have Docker, run the following command in your terminal. Let's shortly explain what we do here. First comes the name catsdb. It's the name of the Docker container we're going to create. This is not the name of the database. Providing a name is useful to stop the container. For example, if we do, this will stop our container and remove it. Let's start it again. Next comes when Postgres starts inside the container, it uses port 5432 by default. But this port is not accessible to you by default. What we do with this part is that we expose internal port 5432 as port 5555 to the outside world. We'll use port 5555 and not the default port to avoid conflicts, in case you have PostgreSQL database already installed locally on your machine, like I have. By default, PostgreSQL Docker image will create a database named Postgres, with a user of the same name. Since it's very confusing, we specify both the username, password and DB name using environment variables. Last part tells Docker that we want to run Postgres 11. There are also other versions available, and you can explore them here. After we've executed the command above, we can check that our database is up and running by executing the following command. If everything went well, you should see container named catsdb. This should be enough Docker for now. Let's go back to our application and start using our database. As usual, we will start by adding some new dependencies to build Gradle. First dependency is for exposed library, which is ORM library for Kotlin written by JetBrains. It will simplify our work with the database. Second dependency is the driver to work with a specific database. So if you choose to work with another database, such as MySQL for example, this line will have to be changed. You can read more about that here. After you've done that, let's run the following command. This will fetch new dependencies. As you see, you'll get an error. That's because, unlike npm, there are multiple repositories to which JVM libraries are published. If you look at top of your build Gradle, you should see something like this. This means only one repository, Maven Central, is being used. But this repository doesn't contain exposed library yet. So we'll add another repository library, JCenter. Run build again and see that it succeeds now. Remember that you can also run it from here. Now let's go to our application main module and add the following at the top. So we defined those variables, now let's use them. Here we use string interpolation. Now we need to specify the driver. And username and password. This tells our application to connect to the database running on the same machine on port 5555. Restart your server and make sure it works properly. For now, our database is empty, so there's nothing interesting going on there. Let's address that by creating a table. Create a new file named dbekt and put there the following declaration of our table. Int ID table means that our table will automatically have a column called ID, which will be both a primary key and auto-incremented. Our table will also have two more columns, one for name of type string and maximum length of 20. Name is required to be unique, as it would be confusing for two cats named Fuzzy to be called for lunch simultaneously. Another column is for age with a default value of 0. Now let's go back to our main model, and after we've obtained connection to a database, add the following lines. Let's restart our application again. Schema utils is used to generate the table in our database. Everything should work smoothly. What we have up until now is a running database with one empty table. To make sure everything works, let's run our tests. In the next video, we'll see how we can populate this database with some meaningful data. And here is the link for the results of our fifth video. In the previous video, we've bootstrapped ourselves a database, but it's still pretty much empty. In this video, we'll finally put some data in it. First, we'll need to expose some new APIs. We could just start adding them in our main router, like we did before, but we'd like to keep everything tidy. So let's create a new package called cats and file catrouter in it with the following contents. That's called a subrouter. We've simply extracted part of the routing logic into a separate function. First, we would like to be able to add a new cat, so we added a post endpoint to our router. This should look familiar if you've been working with some other web language or framework. The endpoint doesn't do anything at this moment. Let's go to our main routing block and use this router. Now we added our router as a subrouter. Let's create a test for this endpoint. For that, I suggest that we create a new test file called cats.test.kt. We'll have a single test in it for now. Make sure that you use the correct imports. It should look very similar to the test we've written in video 4. One of the obvious changes is that we're using post instead of get method. And since we're about to send data, we must also specify the correct header. We use add header for that. If you forget to specify it, you'll receive 405 error unsupported media type from Ktor. Body of our request is a collection of pairs. We've already seen that we can create pairs in Kotlin using to function. The interesting part is that once you have list of pairs, you can invoke form URL encode function on it to convert those values into a properly encoded string. Let's start our database now and run this test. It should fail. Let's go back to our cats router and implement the method now. To read parameters from the body of the request instead of URL, as we did before, we use receiveParameters function. Then we do some validation using require_not_null function. It's a simple convenience method that will throw an exception if our mandatory parameter is null and return its non-nullable variant otherwise. Now we would like to access our DB. Let's create a new file in our cats directory called cat service with the following contents. Using clear and simple interfaces is very important in developing good software. Now you may ask yourself, what's this suspend is for? Ktor is a highly concurrent framework, and you need to tell it which of the functions are blocking so they could be suspended. While a function is suspended, Kotlin can use its resources to run other function. Now let's implement this interface. We can do this in the same file. Since we're going to interact with the database, we need to open a new transaction. In transaction block, we can issue DB statement using exposed DSL. Insert and get ID is quite self-explanatory. We then get cat, which is a new row in a database, which we need to populate. The population is quite trivial. We always set mandatory fields, and for nullable fields we can set them or use some defaults. Now we need to pass the service to our router. Let's first change the signature. Then we'll need to change the invocation too. So we just create a new instance of cat service DB. Now let's invoke this service from our router. So we get it in the signature, and we invoke this method passing the parameters. Let's also pass it in our main module. And now we run our test again. So we still have a failure. Let's see what it is. We don't return the header we expect. So let's fix it. As you can see, our test still fails, but now it fails on unique constraint violation. And that's because this cat was actually already created once, when first our test failed with incorrect header. Let's continue and remember that this test fails, because later we'll learn how we can clean our database after each run. We'll do that in the next video. In the previous video, we added a route that creates a cat in our database. In this video, we'll add another route that will fetch all cats from the database. So, we'll start with a test for this new route. Again, we have this with test application, and inside it we have handle request, and it will be a get request. Initially our database will be empty, so we expect to get here an empty array. In one of the previous videos we created this method called asJSON. Now we just need to import it to convert our string to an JSON object. It was marked private previously, so I'll remove that. And now we can import it. Of course, this will also fail simply because we didn't implement the endpoint. At least not correctly. So let's delete this legacy endpoint and run the test again. Your test may fail for a lot of different reasons. Make sure it fails for the right one. As you can see, now it fails because it actually didn't find the correct path. Now we'll go to our service, and first we need to describe what our cat object looks like. It should be very similar to the database object we already created. So it will be like this. We'll use data class for that. Data classes are a great Kotlin feature that allows us to create very small description for our data. So our class will have ID, name and age, and it will describe a cat. Then we'll add a new function to our interface. It will return a list of cats. And now our service is required to implement this method, so first let's generate a default implementation, and then we'll start to implement it for real. So to access the database we again need transaction, and to access our table we need cats again, and then we have method which is called selectAll, very convenient. Now if you're familiar with Node.js, you're also familiar with map method. It's pretty much common in all modern languages. Now this row is a DB row, and I would like to convert it to a data class. So I would add a new extension method called asCat. IntelliJ will suggest me to implement this method, so yeah, that's exactly what I want to do. Any is not a good option, so result row it is. Let's create a new cat, and its values will be based on the row. In the context of the method, this refers to the DB row. As you see, Xpost makes it very convenient since you have this auto-completion on the columns of our table. What's left to do is to expose it in our router. So we go to our router, we expose it as a get endpoint. If you don't have get, make sure that you import it. And then we use the newly created method from our interface. Everything looks good. Let's run the test again. Yeah, and now we fetched the cat, which is in our DB. It failed our test, but it proves that our DB at least is populated. In the next video, we'll see how to clean our database after each test. And also we'll make sure that our tests from now on are idempotent, meaning no matter how many times we run them, they would still produce the same results. In the previous video, we began with writing more tests for our application. In this video, we'll refactor our application so it will become easier to test. You may wonder, up until now, you always got a link to the latest state of our application. But not this time. Why is that? I strongly believe that if our test fails, never commit it into a repository. Never, really. So, having said that, before we produce anything meaningful, let's go back and let's do some refactoring to our main model. There is a lot of code dealing with database, and actually it should be in the DB file. So we'll copy this and we'll put it inside an object called DB. Now we can go back and organize our imports and just remember to call it. So to call it we need function, let's call it connect. Now let's make all those private. IntelliJ will suggest also to make them const, but I wouldn't do that because later we'll change them back to values again. And now we need to call this function, so let's go back to our main KT file. Let's see that our test still fails for the right reason. Yeah, seems good. And now, as promised, we'll use this function to make some cleanup in our tests. There is a notation called before, which we will use for that. So we'll connect to the database. And then we'll open a new transaction. And schema utils, as well as providing us with means to create tables, provides us with means to drop tables. So that's what we'll do. Now you will see you cannot import this table anymore, because it's not in the correct place. We will move it under its own package. And now it's imported correctly. Now in the real world, you will have a separate database for tests, which may be even created each time in some CI process. But since it's our first application, it's fine to reuse the same database. What matters now is that we have tests and they pass. Yeah, and that's our first passing test. Let's now run the entire test suite. And you should have both of the tests passing. Now it would be great if we could create some cats in our test database and see that they're returned. For that we will refactor our cat creation test a bit. We'll make it an extension method on test application. We add a return. IntelliJ is very useful in suggesting the types you should use. Now let's give our arguments some more meaningful names. And then let's just use those arguments. Let's run our test again. Yep. Now we'll reuse this helper method to create some more cats. So we create a cat and check that it's now returned. At first there should be no cats in the database, and then there should be one. Let's run the test again and see that it fails. And now we should put the correct data. And check it again. Last test method we are going to implement is getting a cat by its ID. We'll copy this, then change the data a bit. This will be a GET request. We import GET, and we check that we get the correct cat. Remember to always compare JSONs, not strings. And then we run the test to see that it passes now. Yep, that looks good. Now let's add find by ID function to our interface. It gets an ID and either returns a cat or null. And now we implement the new method. So again, we open a transaction to access our database. And now we'll use expose DSL to specify that we'd like to get a cat with this ID. In expose DSL, equality in the database is specified by EQ. This will generate the following query. You can see what query is generated yourself by adding add logger function inside your transaction block. Finally, we use first or null to get a single row from the database. And we convert this database row to a cat object. What's left is to connect this new method to our router. So it will be a get method. We're getting the ID from the URL. Then we simply invoke the method that we previously implemented. If the method returns null, we respond with 404 not found. Let's just fix this. First we see that the test fails. Then we just can copy the results and use them in our tests for the next time. And we run the test again and now it passes. Yeah, looks good. From here we have two more methods left to implement: delete and update. I challenge you to implement them by yourself using the same techniques. That will help you grasp the material better. Small hint: update method should use put verb and it should receive ID on the URL and everything else inside the body. If you aren't sure, take a look at the create method for inspiration. In the next video, we'll go over the solution and complete it. And as usual, here's a link to the state of the project until now. In the previous video, I challenged you with implementing delete and update endpoints by yourself. In this video, we will see how to actually do that. We will copy the create cat test for that and change it a bit. The request type should be delete. In this test, we will first create a cat, then delete it. And we're checking that the response is 404 not found. Let's run it. At first our test fails, of course, because we didn't implement the logic yet. So let's go to our interface and add a new method. Now let's implement this method. So first we have this default implementation, then we'll replace it. So we open a new database transaction, and then we use delete where method from expose DSL. We will copy the criteria from the find method. Now we go to our router and add a new path. So it will be delete with ID, and we will import it. And now we copy the first two lines from the get method. And our test passes now. Cool. Let's follow the same pattern and add an update method. So we start with a test. We will copy some of the cat creation logic here. So first we create a cat with particular name and age, and then we'll change it. We'll use put instead of post. And replace some values. Now we go back to our interface and add an update method which is very similar to create. And then we implement it. We open a transaction, you can see the pattern now. We want to update a cat with this ID, but it doesn't seem to work. The reason is in update where is a block. So there are two blocks now. One for the select and the other one how we update the selected rows. That's the reason we have this a bit weird syntax. Setting the fields is very similar to what we did in create method, so we just copy it from there. If you don't want to specify the receiver, you can just use it. It's the default name inside the block. And then the age. Again, same pattern, we add a new route to our router. So, it's quite similar to creation we just copied. The verb should be put now, and we need an ID. Some validations here. And we don't return anything when updating for now. Oh, it seems I'm reading the ID in the wrong way now. I tried to read it from the request body and it's on the URL. Let's copy this and go back to our tests. There's no string interpolation here, let's fix that. And we also return a single element. So I hope during your exercise you did something pretty much similar. With that, we implemented all of the operations our entity may need. In the next chapter, we'll start wrapping our application in a Docker container so we could deploy it. Previous chapter concluded all the basic stuff you need to know about developing service with Kotlin. Now you can create a simple CRUD application that stores data inside the database. Up until now it was running only on your local machine. In the next 3 videos we'll discuss how to containerize your Docker application and then we'll deploy it to a cloud platform. We'll start with containerization. We've briefly touched this topic already in video number 5 while establishing our database. Our Docker command downloaded a Docker image of a database that somebody else prepared for us. Now we'll create a Docker image of our own application. First, in case you skipped some chapters, make sure that you have Docker installed by running Docker command in your terminal. If you don't have a Docker yet, you can install it using this link. Before we even start with Docker, let's go to our build Gradle file and make some changes to it. In your plugins block, add application plugin. This plugin adds a run action that will help us start our application inside the container. Now, if you try to execute your Gradle W run, you'll get an error telling you to specify main class. Go back to build Gradle and add anywhere at the top level the following line. Without it, Gradle doesn't know from which file to start. Notice that Kotlin classes have a kt suffix to their names. Now, if you execute Gradle W run again, your application should start in the command line. Yep. And we can test that it actually works in the command line. You can see that it returns us some results. Next, let's create a file called Dockerfile in the root directory of our project. Then we will add the following 3 lines. First line tells Docker to base our image on an image that has OpenJDK 11 in it. Second line tells Docker to copy everything from directory Dockerfile is located at. That means that our image will contain exact copy of our application. Third line tells Docker that once image has started, it should execute Gradle W run inside the container. Let's now run the following commands in the terminal in the root directory of our project. Those commands are building Docker image of our application. It may take a while. Docker is downloading all the layers it depends on right now. In the meantime, let's understand what those commands mean. Dot stands for current directory, and we could use another path here. And -t lets us specify the name of our image. So our image finally finished building, now we need to run it. We use docker run for that. As in one of the previous videos, we specified the port by using -p flag, and as I mentioned earlier, -t specifies which image to use. Again, this may take some time. If we look at our Docker file, build command executed the first 2 lines and run command executed the last line. So our Docker image tried to run, but it crashed, as you can see, because it cannot find the database. We'll fix that in a minute. But before doing that, take a note that although it's very easy to understand our Docker file right now, after all it has only 3 lines in it, it takes quite a lot of time to run it. So let's do a few optimizations on it. Let's create a file named .dockerignore and add the following lines to it. You can read about dockerignore files here. This file tells Docker that although we specified everything to be copied inside the Docker file, we didn't actually mean to copy just everything. Some directories can just be ignored. This will speed up our build a bit. Now let's go back to our Docker file and add the following lines before the CMD line. Run commands are executed during the build phase. One of the reasons running our image is so slow is that we download Gradle and all its dependencies every time. By adding this line, we tell Docker to run Gradle build only once and cache its results if everything went fine. "-x" argument tells Gradle to skip tests. By default, Gradle build also tries to run them. Optimizations we just did result in that our application fails faster, but it still fails. It cannot find the database although it's running just fine. Reason for that is that although our database is running, it does so on a different network from our Docker container. In the next video, we'll fix that by introducing Docker Compose. In the previous video, we put our application inside a Docker container but couldn't access the database. As usual, there are a few ways to fix that. We will use Docker Compose as it will also help us for the next chapter. Docker Compose is a tool that helps us manage multiple Docker containers at once, like our database or web application, for example. Let's create a file named Docker Compose YAML with the following contents. I'll just copy-paste it here. Now let's run Docker Compose up, and in the meantime I'll explain what this file means. First line just tells which syntax version this file is written in. Latest version is free, so that's what we will use. Next comes services block. Each service is a separate Docker container. You can see that the contents of the cats database service are the same as the command we were using to start our database. And second service web corresponds to the command we started our application with. The only major change is the depends on section. It doesn't make much sense to start our web application if our DB didn't start yet. And that's exactly what depends on does. While I was talking, you could see a lot of colored lines on the background. That's the output of Docker Compose. It seems though that it fails to start since it tried to connect to localhost 5555 and failed. The reason is, with Docker Compose, each service is considered as a separate machine, so localhost won't work anymore. Let's make our application configuration more flexible to accommodate for that. So let's go to our Kotlin code and change the DB object as follows. Instead of hard-coded values, we'll use system_getEnv method. So we'll take values from our environment instead. And let's do it for all the other values too. Now let's go back to Docker Compose YAML and set those values. I'll just copy-paste them here. Now let's run Docker Compose up again. We may get one of two possible problems. First one is that our old database is still running and it will create a port conflict for our Docker Compose. So let's make sure that we shut it down with the following command. Second problem may be that Docker Compose didn't catch our changes at all. So you'll have to run the following command to rebuild your web service. That's my case. It will take some time, so I'll skip ahead a bit. Seems that it has started. Let's now check that it works with the following command. So we can see it returns us a JSON. But does that mean our application really works? Let's try running our tests. Well, that's not so good. Our tests cannot connect to the database. To fix that, in the top right corner of your IntelliJ there is Edit Run Configuration dialog. You should find environment variables there. Edit them and set them accordingly. Let's run our tests again and see that they pass now. Looks good. In this video, we orchestrated our application together with its database using Docker Compose, and we made it configurable using environment variables. In the next video, we'll put those skills to use by deploying our application to the cloud. In the previous videos, we wrapped our application inside a Docker container and were able to launch it inside Docker Compose. It's now ready for deployment to the cloud. We'll use Heroku as our cloud platform, so first we need to register with Heroku. I already did that step, but go ahead and register, it's a quick process. Now let's go back to our project and create a file called Heroku YAML in the root of your project. This file has a very similar role to Docker Compose YAML, but for remote deployments to Heroku instead of local ones. In the meantime, it will contain only 3 lines telling Heroku to build our Docker file. Next, follow this link and install Heroku client. If you're on OS X, it's as simple as brew install Heroku brew Heroku. This may take quite some time, so I'll just skip ahead. Once done, run Heroku login. It will ask for permission to open your browser, and then you just click login button and go back to your ID. Now let's create a new Heroku application by running Heroku create and giving it some name with -a flag. The application has been created. Now we need to tell Heroku that we're going to use Docker to deploy it, so we use Heroku stackset container and use our application name. Next, we would like to add a Postgres database to Heroku. We'll use Heroku add-ons create Postgres and specify our application name. If you'd like to learn more, here's a link for that. Now we need to set up Git repository. This will allow us to push our changes to Heroku. So we run git init, and now we can add git remote. So we add git remote Heroku with your application name. Now we will run a bunch of git commands. Git checkout -b master will create a branch named master. Git add dot will add all files to commit on this branch. Git commit -m initial will push our changes to this branch. And finally, git push -u Heroku master will push our local branch to the remote repository. I already did most of the commands ahead of time, so you'll see me only running the last command, the git push -u Heroku master in the command line. What happens next is that Heroku builds our Docker container, and inside this Docker container, Gradle is being run that attempts to start our application. So our application has finished deploying. Let's see its logs. We run Heroku logs --tail for that. Seems like although our application was deployed successfully, it crashes on startup because it consumes too much memory. In the next video, we'll learn how to fix that. In the previous video, we managed to deploy our application to Heroku, but it couldn't start because it consumed too much memory. In this video, we'll fix that. So we're going to build Gradle, and we start to add the following lines. Previously, we were relying on Gradle to figure out the facts about our application. Which classes to start, what libraries it depends on, how it's packed. This approach has its benefits, configuration was super simple, but it also required a lot of resources. Now we can take control over this process using the jar block. Jar simply stands for Java Archive. Before our application is started, all of its classes are usually packed into a single archive. For Java to be able to run these archives, it needs to have a manifest. Basically, it's a simple text file that should tell which class to run first. That's the main class that we have there. This archive doesn't contain all of the libraries though, which is alright for the development phase, since at this point we use library cache on our own machine, but for production we want to pack all those libraries ahead of time, producing what's called a fat jar. That's what we do in from block. Finally, our jar name is usually based on the name of our project and its version. But since we would like this name to be consistent, we use archive name to specify a static name for it. Next, let's change our Docker file. First, we will give a name to our first layer. Let's call it builder. Then we'll replace Gradle build with Gradle jar. And we will add a second layer with a default name. In Docker terms, that's called a multi-stage build. It allows us to finally control the build of the image, and it produces smaller images as a result. At first stage, which we named builder, we copy all the files and then tell Gradle to pack them, producing a jar. Then in the second stage, we copy only this fat jar file into our Docker container and we run it without Gradle at all. So we just specify java minus jar and the name of our jar file. That's why we gave it a constant name. Now I'll go back to the build Gradle file and move the main class higher, because I'm not sure it will work the way I put it right now. And now let's run docker compose up to see that everything works. So everything looks good. Now let's test it with curl. Yeah, it works. Now let's add changed files. So we add them with git add, then we create a new commit. And we push it to Heroku. This again may take some time. Okay, all done. Now let's check the logs again. We can see that the application doesn't run out of memory anymore, but it cannot connect to the database. In our next video, we'll fix that. In the previous video, we solved memory issues we had with our application, but it still doesn't work because it cannot connect to the database. We'll solve that in this video. Let's first go to the main KT file and instead of hard-coded port, we'll read it from the environment. It's very straightforward. If there is one, read it, otherwise use the default port. That's one problem solved. Now let's go to the dbkt file, and Heroku provides DB connection properties in one string. Host, port, everything together. So we need to deal with that. We'll have a constructor or an init block, and now we need to read the environment. So Heroku calls this parameter database URL. And then we check if there's such an environment. If there's no, then we do what we did before. And let's select this part. And now we need to split it into separate parts. So there will be port and the host and all the others. So creating URI from string helps us with that. And now to read the username we need to split it because it's joined by a semicolon. Now we just need to set the types because they cannot be inferred anymore. So those are the types. And this is now a number. And here I forgot to remove the first character. Now again we add all our changes, we create a new commit, and then we push it to Heroku. It again takes some time. And now when everything is done, let's see the logs again. Seems like our application is finally connected to the database. So let's run Heroku open and see what it looks like. And that's our browser, and you can see that our application opens. Now let's try to add a new cat. So we go back to terminal and we do this command. Feel free to stop the video. And it's a bit hard to see, but this command returns us a new ID. Now let's view all cats in our database. So we run this command and we get a JSON with one cat. We can see that that's the cat we added just now. And finally, let's remove it. So that's the command. And we check a list of cats again. And we get no cats. So our application works as promised. Congratulations, you just completed this course. Let's now have a short summary of what we have achieved in this course. First, we have built a microservice using Kotlin and Ktor framework. This microservice is fully tested, having nearly 100% coverage. It's integrated with PostgreSQL database using exposed library, it's containerized, and it's deployed to Heroku. Congratulations, we did that.